You know, as I stand here looking at this set of prints laying in front of me, there are so many different components. And to work smart is to work efficiently. It's good to put all of your round pieces together at the same time. It's good to put all the pieces that need to be milled, any kind of secondary, do that all at the same time. These components that get the dovetails for the cross slides, for the carriage, for the apron, anything that needs to be done with special tooling, 45-degree cuts like this, that's all going to be done with the same cutter. This is also going to go with the tailstock casting. So mentally plan your project for the best results. Another thing I do is go over each component and see if there's any note on that component, because it's real easy to just see these little hashtags and think, well, you know, they're talking about a drill size or something, and just blow past, completely past whatever they're trying to convey. So I'm going to highlight these prints just to call my attention to the fact that, okay, there's special handling, there's a press fit, there's an assembly note, there is something on these prints that the manufacturer wants you to know. But I keep on coming back to this guy right here. I just finished my forge jaw, and thank you for all the positive feedback and comments on that. I was really pleased with that. This guy has the infamous T-slot that we really can't get away from. Well, I could do it the same way, but this is a soft cast aluminum, and I think it's probably going to be easy to just chop up a form tool and do that. And when I say chop up a form tool, I mean grab a 3/16 center drill out of your box and your Dremel grinder and make one. And that's exactly what I'm going to do. Now, to look at this, you think, yeah, no big deal. This is one of those parts that you get into. You're having a good time with it. And then halfway into it, you go, uh-oh, you scratch your side of your head and go, how am I going to do that? And the how am I going to do that comes from these slots right here. The T-slots, not so much the fact that it's a tiny little T profile in it, but they are aligned with elevations on the back side of the part. So when positioned this way, it's one of those things that you can't see. And I think that we've come up with a fairly creative way to overcome that problem. This is also one of those pieces that you can do 99 different ways. So I think the best thing to do is just lock your mind in on which way you want to proceed, since you only have one, and do it. Let's get it started. Anytime you're turning aluminum and you're just getting a nasty, sandy, ugly finish on the outside, check the nose of the tool. Chances are the nose of the tool has broken down and it's just not doing its job. Or the point on the tool may be a little too aggressive. Look down here as the shadow comes across the part, and you can see the difference in the surface finish. And additionally, I want this diameter all the way turned to those elevations in the back, so I'm going to change the tool over. I'll be back. Okay, got the light turned down a little bit here to offset some of the glare. Tools are dialed in, let's hit some numbers. That is some really gummy material. Make sure your tools are extra sharp, that no material is stuck to your tool, and use some lubrication on the final passes. There are some creative terms for the material that clings to the tool, cold welds itself to the tool, but I'm not sure that the YouTube would approve of what I call it. With a crappy matte finish like that, you know there's something stuck to the tool, so clean it off. That's better. I am using a thread undercut tool to get down inside the recess. Normally it's for internal work, but it's going to work just fine for this one. Set up complete. Let's face it off the thickness. Actually, I'm going to face it off close to thickness, then I'm going to verify parallel by indicating the back side. Then I'll finish it. Okay guys, here comes a shop gem for you. This part is about 4 thousandths out of parallel right now because it was just put in that collet and faced off. It is still oversized from the final dimension, but it is out of parallel. I'm going to put an indicator on the back side because when I face the front, I want it true to the rear. When you put your tool to the part, it's only going to hit on the high spot. So when you take the part out and you inspect it, find the thickest value that you can find around the face of that part. And when it tool makes contact with the part, that's the number that you're going to use for your carriage shift. So if it's out of parallel to begin with, you need to find the thickest part initially and work with that number as your value. It is 196 right now. I'm shooting for 187. Register the indicator needle on the back side of the part and get it within a reasonable run out. Now bear in mind this was a pressure turned operation, so any deviation you see on this side could have been translated from the first operation. But that is about a 7/10 total run out. I'm okay with that. It's going to work. .196, shooting for 187. You will see the intermittent contact when the part starts. This is a 9/1000 final pass. Watch for the intermittent hit. It's the high spot. This is a piece of 3/0 steel wool. You can get it at the home center local to wherever you're at. I get it at Home Depot, plumbing department, floor finishing, whatever. Nice and fine. Going to use a little bit of WD-40 with it. Works well with water as well. Watch this shine. That is a finish without polish. Not bad, huh? Quarter 28 through. We are back on the small fixture plate from the steam engine series for the slots. And since we cannot see these elevated ribs when you flip it over to do the work on the face, you're going to need some type of landmark to track it or a fixture to track it. I have two of the small clamps secured to this base plate in the back. That gives me one advantage. I can push this against those clamps because the clamp height here is higher than my spacer, and that will allow me to spin this without losing concentricity. So the first thing I'm going to do is push this against those two clamps, clamp it down gently because this is very soft and you will dent it. So I'll clamp it down gently, indicate it true, and then once it's true, I can unloosen the clamps and use a pin, which I have right here, in the drill chuck, and I will jump the center boss until I have the rotation lined up. When one of these bosses comes around, I want it to be in line with the pin. then naturally I'll check all 4 corners by just jumping the boss and doing it. And if you're not sure exactly what I'm talking about right there, I will do all the indication and alignment off camera, and then I will show you exactly what it looks like when it's correct. First step, push it in, lock it down, indicate the center boss. Anytime you have an indicator that is tracking absolutely beautiful on the dial, move the body of the indicator, watch the needle. Make sure the needle goes both ways beyond where it's sitting so perfectly still. That way you know it's not maxed out. I've actually seen a lot of users, new users, max the needle out and run the indicator around the part and go, holy mackerel, I got it perfect on the first try, but you don't know if you do until you give it one of these. So go for the commitment wiggle or confirmation wiggle and give it one more span. If it still doesn't move, zero out all your dials and DROs and you know you're home. This is where we put a pin in the vise and set rotation. Concentricity is set, rotation is not. Let's do that. My digital readout is now set to 0, 0, X and Y. And my 196 pin has seen better days. I'm going to come around the front of the part here so you can see this. Actually, I'm going to do it on the side so you can see it. I think that's a better idea. Let's do that. With my 0, 0 set to the center of the part, you can see the pin coming down through the thread. I'm going to move off to the side just for demonstration purposes. When it comes time to do this for real, I will do it in line with one of the zeros on the axis. Bring the pin down where you can see it. Unloosen your clamps. And while maintaining pressure to the rear of the part, to the rear of the setup. Boy, that's a really nice picture right there, huh? While maintaining pressure to the rear of the setup, rotate the part until the pin lines up with the boss. Like that. Okay, that's exactly what I'm going to be looking for when I go forward and reverse with this. When this is set, when the pin is set to an X0 or a Y0, and I move it accordingly across the opposite side axis, when that pin lines up with that rib, my rotation will be set. And there's a reason for that, so just let me do it, lock it down, we'll come back. My rotation is set and locked. I am sitting on 0 for my Y-axis. Using the X-axis, which is left and right on the screen, this way, that is my X-axis. I'm going to shift off and look at the rib. Visually align the pin to the rib. Jump the center boss. This is what I was talking about. Come over this side and check it out as well. If there's any rotational mismatch, since you're against your stops, you can rotate it without losing the center setting. I'm going to come back to 0 on my X. Do the exact same thing in the Y. While bumping the tripod with the handle of the machine. Same thing with the Y. Look at the alignment of the back. Jump up around the front, double check it. Now you are at the mercy of the casting at this point. If these are not square and they're not symmetrical, they're not all true to where they should be, you're going to see a problem. But once you're happy with the alignment, go back to your 0 point and start with your math. I'm going to put 4 holes in this plate at the ends of the 45-degree slots in the recess. That's why I have the plate underneath. This is a piece of acrylic. I'm going to drill through this into the acrylic and establish the 4 outer boundaries of the 45-degree slots. If the initial concentricity of this part before you turn the OD was out, this is where you're going to find out about it. I am trying to put my 1/16 holes as close as I can to the inside edges of this in a precision pattern. And the precision pattern is going to be so I can rotate it and use those pins in a different setup to find these bosses when I'm inverted. So I have a 1/16 4-flute end mill in my chuck, and I'm not a big advocate of it, but this is soft like clay, and the 4-flute I know is razor sharp. Not side loading the cutter. I'm just going to spot face it so I can drill. And I did a little bit of math off screen to come up with the values that I will be using. So let's do it. You know, I'm so confident with this setup, I think I should just go straight through it. I think I'll do that. Let's move and figure out how deep to go. If all went well, I now have 4 through holes in this plate. That I can trust as pinholes when I flip it over. Let's put another little sacrificial plate on here, flip this thing over, and get it done. Little mid-plan shift here in between setups. I'm going to remove this back boss down to the final height of 187 and put the counter bore in. It'll just make it a little easier to put the slots in if this isn't so tall. Since I'm not going to use it for anything downstream, it can come off. .250 counter bore, dead center, 1/8 of an inch deep. Threw together a fixture plate for the next slotting operation, and you can see 375 hole in the center will coincide with the 375 boss on the back. That will give me my concentric and rotational control. And then I have 2 16th holes on the x-axis, center line 0, and 2 more offset. They will coincide with the 1/16 holes that I put in there originally. The 2 on the x-axis will give me a true alignment, and the 2 that are offset will give me the 45-degree alignment for the T-slots. So there's really no messing around here. You could do this on a rotary table, yes, but for those of you that do not have a rotary table, this is a fantastic option. Anybody that's going to say, why don't you do it in a 3/8 collet and just line it up with pins and stand it up and do it in a V-block, yada yada. There is always some degree of movement when you tighten the 5C collet down in a collet block, and you could be here for quite a while trying to get it to be oriented correctly. And then you have to worry about it being in the collet correctly as well. I'm going to go with this. I think it's going to be a legit way to go. I'm going to do the 1/16 slots first. We'll be back when it's clamped up. Part is securely clamped in the fixture, and you can see the 2 alignment pins with the 1/16 holes from the previous operation line up with the 1/16 holes in the fixture plate. These are for rotational control. As I mill the slots, I will remove those, so we'll just have to rely on the pressure from the clamps. There's really nothing else to say. It's a 1/16 4-flute cutter. I am going to peck away at this. It's not very thick, but it is gummy material, so let's just knock it out. I'm going to see exactly how long this takes. It is about 3 minutes till 2 o'clock. Real time on those 4 slots, 7 minutes total. If you want to go back in and walk a couple thousandths offside, either way to clean up any peck marks that may be present, now would be the time to do it before you remove the clamps. When I take those clamps off, all I need to do is go 45 degrees, and the bottom 2 slots on this side will line up with the other 2 holes in the fixture and put me right on position for the T-slots. I'm going to clean it up, I'm going to rotate it, we'll come back for that. A quick look at the rotated utility of those other holes that were put in. First 2 are right on the x-axis, and these 2 are offset from the x-axis. So this gives me the 45 degrees I was looking for. And now it's time to do the exact same thing with an 075 end mill. It is called out as 075 on the print. You could do it with a 1/16. I probably will do it the initial cut with a 1/16 and finish it with the 075. They are available online. You can buy 075 decimal end mills. So I went ahead and did it. It's about 18 bucks. Not a big deal. And then we'll hold our breath for 20 minutes while we cut the T-slots and hope that that doesn't snap off and ruin our day. All right, let me reclamp it. We'll get to it. Very difficult camera angle here, but we're going to go for the T-slot. I am going to rough it out with a 16th cutter and go back in with the 075 before the T-slot. I want as much material out of there as I can. Last actual clock time on the 4 16th slots was about 7 minutes total. Okay, very much like a real T-slot, I am going to take this 1/16 cutter a couple of thousandths of an inch below the finished depth of the T-slot. That way when I go back in there with the 075, it only opens up the top, and the T-slot cutter itself only opens up the sides. It will not drag the bottom. If you take a look at many of the T-slots that are currently out there, you'll find that there's a small trough in the center. And just for safety, because of the tool is so delicate, I am going to make the center deeper so the bottom of the tool only cuts in the relief area and not across the entire face. There should not be a noticeable change to the design. Faceplate. Going to change over to the larger cutter, and we're going to go just shy of the bottom of the feature I just put in there. Same exact trajectory. We're going to stay a little bit further away from the center so that the tangent points of all the different cutters ends up on the same basic diameter. New cutter is loaded, 075 diameter, 2 flute, high speed with an extension. I am going to stay 2 thousandths away from the bottom of the existing slot. At least that's the plan. Let's see if that works. Oh, 75 slots, 125 deep, 4 of them. And boy, this is getting dirty in here. Let's put the T-slot cutter in, see if we can make heads or tails of that. For anyone that has never used extremely small cutters, all those chips that you see laying around are like, it's like sand. Do yourself a favor, and for your final cuts, if you're going to use a delicate tool like the one shown on the screen, right dead center, that's a 3mm diameter, neck down to about 1.5 millimeters. This is a very small cutter. Make sure that if you're going to use coolant on the back side of this or on the final operations, that it's clean. Get as much of this garbage out of there as you can. It's only going to lead to friction, and friction leads to bad things. And I don't feel like throwing this across the shop right now, so my coolant is clean. You wouldn't believe how small those movements are. There we go, perfect. So let's zero this tool out on the top of the part, drop it down about 125, and see if it goes through. This is the tool that I made earlier, and I did round some of the edges off on the sander, actually on the Baldor grinder after I was done with it. So let's go. Let's keep your fingers crossed on this one. This one I'll be sweating on. Yes, I will. Don't forget that the target number continues to increase as the diameter increases. If you want all these radiuses to end up tangent to each other, you must stay farther and farther away from the center of this part. If you want it to look like a real one, which I do. All right, here we go. Fingers crossed. right, looks like the cutter's still there. That's a good thing. And it looks like a T-slot to me. That's a win. Yeah, baby. Get some of that hooey off of there without blowing it all over the camera. There you go. You can see the smaller relief in the center. That takes some of the stress out of the cutter. And it definitely looks like a T-slot, so that's a wonderful thing. There is no sense in showing the rest of this. All I'm going to be doing is holding my breath, turning blue. So as soon as this is done, before I unclamp it, I will get the camera back in here. And wish me luck. Here we go. All 4 slots are done. That is a win. I am very pleased with that. Cutter held up very well. It cut real nice. That primary 40-degree angle on it, that just cleared the chips right out of there. Well, it's time to get oily and break all this down, clean it up with some alcohol, put it on the bench. We'll get a closer look. It is all deburred, cleaned up. This is about, what is this? It's about 33 millimeters in diameter. About 4 millimeters thick. That little T-slot cutter worked out very well. And you can see the technique used with the smaller cutter does take some of the load off the bottom of the tool if that's how you have to proceed. Small inclusion in the casting, and I'll have to just live with it. And you know I can't let well enough alone. I'm going to have to make T-nuts for this, and I'm going to have to make straps, and I'm going to have to put a square block on this and do something with it. So for all you guys that are going to just probably already typing, where's the grooves? My lathe is tied up right now, and I cannot put those grooves in there right now. I probably will add them before the end of the build, but for now, that is just going to have to do. If I can get a different non-glare shot on that. Another nice addition to the tool caddy. I'm going to put this right alongside the 4-jaw. Oh man, if that hit the floor, I would cry. Thank God it didn't. Long day, people. I am about ready to get out of here, and it's a nice sunny day here in Texas. It is 70-something degrees today. Beautiful. Northeast of the United States got hammered with snow. To all my buddies up there in the Northeast, I feel for you. I will feel for you while I'm sitting on my deck having a beer. Anyway, Joe Pye, Advanced Innovations in Austin, Texas. Thanks for watching. Stay well. I'm out.